everyone, welcome back to my channel EduVibe. Today we will start with the second topic of the momentum and impulse unit, which will start by the previous lesson, which is the momentum. Today we will do the impulse. So firstly, I will tell you that the impulse is like the topic which we have to learn in this. So impulse is the sum we have to do the graphs too, like you see in this. We have a force and a time graph, which we deal with later on lessons. Start with the impulse. So as I told you in the previous lesson that the impulse is the change in momentum. So is it like impulse is a change in momentum which has a delta p. It experiences due to an external force being applied to it. Because the impulse is the thing where the external force can be applied. Momentum is the thing where the external force cannot be applied by that much as the impulse. So impulse is a change in momentum and it has the due to the external force. So as I derive the equation from the previous previous lesson of momentum, like net force is equal to delta P upon delta T. But now we know that that delta P is change in momentum, which is impulse. So if we want this thing, so you can that delta P isolate and that net force times delta T. From where you get this formula. Where that delta P is change in momentum, kg meter per second or Newton per second, don't care about this. Net force is in Newton, interaction time is in second. For the delta D is the interaction time, that how much attraction will occur due to the impulse, the change in momentum, how much that attraction time will be. So it's recorded to this. If the momentum is the vector quantity, so this means the impulse is also a vector quantity with its direction being as same as the net force or a change in momentum. Change in velocity and the net force have the same direction as the impulse. So you're now thinking about what is that velocity, change in velocity. So from here we will derive another formula for impulse. So let's derive that another formula for impulse where we have a delta v, which is change in velocity. So how can we derive this? Well, we have to know that what is delta p. Delta p is pf minus pi. Where you further write this as mvf minus mvi. From here you can take that m common and you get vf minus vi. So now, like always, that so what is vf minus vi? So it's delta v. So there's another formula which is change in momentum with delta p is equal to the mass into delta v. That delta v is your change in velocity. This one. So that's how you can have the two formulas for impulse. For the third one, if you want, for the third one, there's only one formula you have to learn, that you know that delta P is equal to net force times T, and now you know that delta P is also equal to m delta V. If they both are equal to delta P, which is change in momentum, so they both are equal to each other too. Like the net force delta T is equal to mass delta V. So that's the thing you will know now. That this formula is on your data sheet. If you know this formula from data sheet, so we know that both are equal to delta P and you can find that. So now let's deal with the examples for this. And one more thing which I will discuss after this example and the last part of this example too. So on a head-on collision, so from here we can just tell you that I just want to tell you that impulse and momentum all about the collisions and explosions, which we will also deal later on lessons. So the head-on collisions, 2500 kg truck traveling 30.0 meter per second west crashes into a car. A car rebounds from a crash with a velocity of 7.5 meter per second. When they crash, they rebounds on the direction of east. The traction time of the collision between the truck and the car is 0.350 meter per second. Determine the what? You have to determine the impulse experienced by the truck due to the car during the collision. So during the collision, so what is the change in momentum in this? So from here, you know that our VI is this, that they're traveling on that speed, which is 30.0 meter per second. This was the west or east, you have to know. Our final was this, because after rebound they go from this, so this is the final. So we put 7.5 meter per second. Okay, now we also have a traction time, which is delta t, 0.350 seconds. We have mass 2 of 2500 kgs. We have these values, but we want to find delta p, and we have delta v, like final and initial we have, so we can find from here. So mass is 25 kgs. You know that delta v is equal to f minus vi, so I just write this. So final is 7.5 meter per second, minus it by 30.0 meter per second. One thing that, if we have to take something in positive or negative, if we get east as positive, so we take west as negative. So this 30 should be negative because this is west, and this should be in positive. So you must take that thing over there because this is the vector quantity, change of momentum, so you have to deal with this directions too. This is the minus. So delta P, when you calculate all the thing, you will get about 93750 kg or meter per second. 3 say this, so this is equal to 9.38 into 10 raised to power 4 kg dot meter per second. This is in east direction because we get this in positive. So this is how you can deal with the type of sums with this formula. Next one, you have to find the net force exerted on the truck due to the car during the collision. So for the net force, you have a formula for this, for the same one. So you know that delta P is equal to net force times delta T. You want that net force, so it's delta P upon delta T. So from here, you know that you find this thing. From here, you can put this, put the non-rounded value, which is 93750 kg dot meter per second, and time is same, which is 0.350 seconds, and you get about net force. You want in 3 set this, so it's 2.68 into 10 raised to power 5 newtons. Again, you get this in positive, so it's in east direction. So this is your answer for net force. Now for the last part, you have to find the net force out on the car due to a truck during the collision. How do you know? So for this type of question, here you find that the net force out on the truck due to the car during the collision. Here is told us about the exert on the car due to the truck during the collision. There's an opposite one. So if there's an opposite one, so you don't need to do nothing for that C part. What you just write that net force is equal to same as this net force, which is 2.68 into 10 raised to power 5 newtons. But this is the opposite one. This is a truck to a car collision. This is the car to the truck due to collision. So you just write this net force is 2.6 into 10 raised to power 5 newtons, but then this should be in west direction. So how do you know this? So this is by Newton's third law of motion. Because Newton's third law states that the For every action, there is an equal and opposite direction for this. There's an equal and opposite reaction for this, so it is an opposite direction for this. If there is a straight to the to car, and then we have a opposite for this car to it, so they have the equal direction on the both. So they change the direction from east you get the west. For this question, we didn't want to find like the other part, the opposite part of this, but only in case of the forces, not for the momentum. So this is all for this lesson, the impulse one. So learning is simple with EduVibe. Learn smarter but not harder. Please like, share, and subscribe to my channel. If you have any questions, let me know in the comment section. In the next lesson, we will start with some the theory part of this unit, which is related to again with the impulse. Then we move forward on to the another thing which we have to cover in this unit. So till then, stay connected with EduVibe.